Okay, today I would like to show you how you can create a Ammonite shell. Looks like these images using Houdini. And a lot of times when you search image with the keyword fractal, you see a lot of these images, the Ammonite shell or the shell of the nautilus. And simply the basic algorithm how this shell is made of is this logarithmic spiral like these using the log equations to calculate the angle of this each spiral curve. So I would like to implement those in Houdini to make this kind of curve and also create a shell that looks like this. Okay, let's do that. And this gonna be a bit a really simple thing, I think. So first of all, let's create a curve, spiral curve using first of all, I need to make a geometry, as always. Let's get in here, delete the file, and let's start with the point wrangle. But since there's no point on the first time, so change this to detail, and let's create some points to be a base of the spiral position. Spiral curve control points positions. Now first of all, I need to set how many numbers of points would I need, so let's make another node called null and name this controller and maybe color this and set some parameters here. Now first of all, what I need as a parameter is the number of points. So let's set the integer here and call it num. And the range could be like around 0 to 1000 or maybe 500. And okay, let's apply this, and also let's go back to the Wikipedia and see what kind of parameters that I need. Now first of all, in order to create the angle for the spiral, I need two parameters, B and A and R. So three parameters, I guess. And R stands for the radius of each position in spiral, if you take it as a circle or arc. So let's set three parameters, or I guess two parameters is fine for now. Let's do that. Now I need A and B. I just call it A here to make it simple. And B. Okay. And let's apply this and go back to the point wrangle. I'll name this create spiral. And let's get the parameters here. Float A equals CHF. Controller A. Float B equals CHF. Controller B. Okay, and also I wanna get the number of points here, so integer num equals CHI. Controller num. Okay. Now since I'm gonna make a single curve, I'm gonna make a prim first. Add prim as a polyline. Okay, and let's use a for loop to create a points for this primitive. So for integer I equals 0 to a number of points and iterate by 1. So first of all, let's make a radius, or yeah, I guess the radius. Float r equals let's say for I right now, and float theta, which will be the angle of the spiral for each r position for each the radius of r. So that will be calculated with this equations. So that will be 1.0 divided by b times log and all divided by a. Okay, and let's use the vector to actually set the position for the spiral points, spiral control points. So the first thing, you can also check the wiki how you can calculate the x and y coordinates for the spiral. So the x will be r times cosine t, and yt equals rt times sine t. So that will be, the x will be r times cosine theta, and the y is 0, and the z is r times sine theta. And make a point at this position. Okay, has to be theta. And do I get any points? This was... no, I don't seem to get anything. Okay, let me check the geometry spreadsheet. Okay, I don't have anything here. So, okay, I didn't put any numbers here, so it's to be 100. And I do see something here, and I have to set A and B as well. So let's change that. And yeah, I kind of already see some changes here with the spiral value, spiral look. So let's change it to something like 1 for A. If you look at A, if you change the value A, it's just rotating like the whole thing, so it's not really important what A does. So I'll just set to 1, and let me set the B to something lower than this one, like maybe 0.17 will be nicely done, nicely drawn as a spiral, so I'll use that. And for the number of points, maybe I wanna make more numbers and zoom out so that it will look more dense spiral and looking already like a Ammonite shell or nautilus shell, and looks good. So let's go with this. Okay, let's go back to the create spiral point wrangle or detail wrangle, and what else I need to do? I need to make it as a polyline here. I only have points right now, so let's use this as our vertices. So int vt stands as a vertex, add vertex prim pt, so convert the pt to vertex, and now I have this polyline, nice polyline. Okay, now if you look at the image of the spiral, I mean the shells, the Ammonite shell, especially the section of the Ammonite shell, you'll see there's a partitions exists inside the shell, which is kind of a partition that gives a site filling a room to move around. So I would like to make this partition as well. Now the interesting fact is that the way it the direction how this arc of this partition looking at or forward to will be is different by if it is a nautilus or ammonite. So the nautilus is going inward like this, but if you look at the shell of the ammonite, it goes outward. The arc goes outward. So I would like also to make a parameter that you can change between ammonite and nautilus as well, so that it will be more parametrical life being. Okay, let's do that. And also you see that the thickness of the shell is becoming thinner and thinner when it gets close to the center, and so I also would like to make that effect somehow in Houdini. So in the end, I would like to use a function like sweep in order to make a thickened pipe. So in order to change the radius of the pipe for each point, I need to set p scale for each point. So let's do that first. Now the things I want to change right now is that if you look at the center, the quality, the resolution of the curve is a bit low res, hence the outside is more high res. So I would like to make the center more high and the outer to be a bit less. So in order to do that, what I need to do is to change the bit of this r, the radius function. Right now I'm just using I, but if I use the power of 2 for I, something like I times 0.01, then what I will get, the whole thing is I would get a bit smaller, but if you zoom out, you see that on the center it's more dense, and when it goes outside, it got more less dense. So that's what I want for now. Okay, and so I have the vertices. I would like to add the p scale as I said before, so I'll set it here. Set point attriv 0 p scale for each point to be something like, well, what it can be is that could be r, which is the radius, times a since the angle is kind of defined by the value b, I could probably use b here. And another one, I guess I need another parameter here. Maybe I'll call it scale. So let's make a parameter scale here. Scale. The range could be like from 0 to 1. Apply. Accept. Let's copy this parameter. And, well, I'll just say scale equals CHF controller scale. Now, I don't really see the changes right now, but if you look at this geometry spreadsheet, you can see the P scale is added for each point. Okay, that's good. And what else I need? I need to set the position of the partition for the shells. So let's do that. Okay. Well, since it's the partition is set at specific or some seasons, series of distance. So, and obviously I don't want to put the partition to every points that I created for the spiral curve. So I will use a condition like this. If I which is the number of point modular partition sep. Okay, this partition sep is another parameters that I'm gonna set equals to 0, and also num, the whole number, the total number of points minus partition sep is bigger than I, which means I don't want to put any partitions on the end. So that I'm just making sure to not to do that with this last condition. Let's set the group for each point, whether it should have a partition or not. So set point group 0 partition at pt 1, else copy this and set it to 0. Okay, and oh yeah, so I don't have our parameter partition sep, so let's make a parameter integer partition sep, partition separation number, partition sep. Okay, and apply. Maybe it could be from 0 to 10, accept, and maybe I'll set to around 3 to 4. I'll copy this parameter and let's go to this here and make let's import the parameter here. So int partition sep equals chi controller partition sep. Okay, and now if you look at the geometry spreadsheet, you can see for each fourth points, you have this partition number group to be set to 1, where the partition should come. Now this is enough for the first initial setup. Okay, what I can do, let's make a partition first, the easy one first. So in order to place the partition here, I'm gonna make a partition based from the sphere, but I would like to get I need to cut the sphere into half size so that it will line up with this curve. So in order to do that, I need to first have a normal distance or tangent vector for each point on this curve. And if you look at this, I don't have any normal value here right now, so let's make some poly frame. Okay, if you look at the poly frame, I can set a entity to be primitive and style to be 2 edges, and I don't want the normal name to be n, but I want the tangent name to be n. So in this case, if you click this normal toggle on, you can see now that the normal is heading to the normal, the tangent vector of this point position. So that's good. Now let's make a base for the partition here. Okay, well, since I said it's gonna the partition's gonna be based on the sphere, so let's make a sphere first. Sphere, and let's make it polygon, and let's set the uniform size to be a bit smaller than 1, and frequency, meaning the quality of the circle, could be like around 4, could be more, could be less. Okay, now after this, I need to cut this sphere into half so that it looks like the one in this image. So let's use I don't know, maybe a box to cut it out, like using Boolean. So box, I'll set the box here, and let's set the size to 222. Okay, and I also need to move this to Z direction somewhere around here, but I need to move like half size of this box bounding size, which is like well, maybe I can set this size to be 1, so the half size of 1 will be 0.5. Okay, now I can use Boolean to actually subtract A from B using the subtract. Okay, and the result will be this one, but I don't want this face to be produced. So in order to separate the outside and the inside, maybe I could use the first one to be surface. Yeah, and that will work. Okay, that's good. And now, as I said before, well, let's just copy this to the point on the spiral position. a spiral curve so that to see how it looks like. Okay, so what I can do, I can copy stamp, and what I want to copy is this subtracted sphere, half chopped sphere here, and 2 the points on the spiral curve. Now I don't want to move this to every position of the point. I just want to move on the where the group is set to a piece partition. So I'll filter the template group to partition, and now I don't see anything somehow. And let's see why. So it's called partition, and the group I made here is called partition. Okay, partition. Spell mistake. Partition. Okay. Great. Now I can see that the scale of the partitions is a bit small, obviously. So if I increase the scale here, I can see that it's increasing the value. And I am still not sure if this is correct or not. Now I guess I can increase more of a scale. Maybe the maximum one is a bit too small. Let's set the scale's maximum to be 10. Apply. Yeah, this looks correct. And maybe partition separation of 4 is too much. I mean, too close to each other. So if I can increase here, something like this. Yeah. Now, this partition could be good. Now, as I said before, this direction of the partition could be changed based on whether it's Ammonite or nautilus. So right now, if you look at the image of this nautilus shells on Wikipedia page, it explains that the arc which goes inside towards inside is a nautilus, but for this one it's going outside. The arc is facing outward, so this means it's a Ammonite. So if I flip the direction of this arc, then it will become a nautilus. Well, logically, I guess. I mean, it's not just that, I guess, but it's one of the characters for which each shell has. So let's make that parameter to switch between nautilus and Ammonite. So in order to do that, I could make a parameter. Which parameter should I use? Toggle? No. Float button. Float vector. Oops. I could use, okay, this one, button strip. I will call this type, and I think I need to set the name for the type. I think if I go to menu, okay, I think I can set a value here. Let's set the first one to be Ammonite, and the second one to be nautilus. Okay, accept. And okay, this is not good. I just wanna check only one of those. So let's go back to the button. Let's set to normal, menu, only single selection, apply. Okay, now it's toggling between Ammonite and Nautilus. So let's copy this parameter and use it inside the... where should I use it? I guess I should use it on Boolean or this. Okay, yeah, here. The position of the box to subtract the sphere. So right now it's on this side. So if you switch the parameter type, I would like to move this box to this side. Okay, now let's do that. In order to do that, I can just say 0.5 minus ch controller type. Okay. Now let's look at the Boolean and change the type. Now it's changing the direction. And if you look at the copy, yeah, the direction of the arc changed. Now that's good. Now I guess it's all good for the inside partitions. Let's make the outside shell, which is kind of a main part of this geometry. So first of all, let's go back to this create spiral and show the points. Okay, and let's make a sweep. And for the curve should be on the backbone. And for the section, cross section, I guess I should create a circle to actually make a sweep geometry. So let's make a circle and connect to the cross section. Now I see something like this, which is not what I expect to have, so I would like to change the output to skin unclosed, and it's not showing anything. I should change the circle to polygon. Yes, and now it looks like a shell. Yeah, the resolution is a bit too low. I would like to increase the pigeon number here, and the radius of the pipe, which is a P scale, which is used to P scale, is also which was also used in for the partition size, is set here already. So this the scale of the pipe, the depth or the radius of the pipe could be controlled using this scale parameters like this. Okay, now that's good. Let's merge together those two. And I could probably use a normal to make sure that there's no hard edges for big number of angles, and also I would like to show the section of this Ammonite shell or nautilus shell, since it's a bit boring if you only see the outside of the shells when you have this partitions already existed inside. So let's try to make a interactive parametrical sectionize function. Now to do that, let's first make a bounding box of this whole thing and transform this a bit above. Maybe for this, to how much I should make it go above, I can make a parameter. Maybe I can set the parameter called section. Okay, and could be from 0 to 1. So if the value is 0, it's just showing the whole Ammonite shell from outside. If it's the section value is 1, then I would like to chop the shells into half so that you can see the section. Okay. Now I can copy this parameter, go back to the transform, and okay, what I need to change is just a translate value for the y, I think. So let's do that. First of all, I need to know how much the size for the bounding box y edge, y size, and I would like to use that to move this upward. So first of all, let's get that using beatbox, and you want to reference to yourself, so I will write like this, and the y size, okay, and times I would, let's check if I don't get any errors, and it seems fine. Okay, now times, I need to 1 minus the one I copied, the parameter section, times 0.5. So if the section value is 0, it's whole way up, and the geometry is around here, so it's not intersecting. But if I increase the value of the section and try to increase, then if it gets to 1, the Ammonite shell will be chopped into half using this boundary. And in order to chop, you need a boolean, as I used for the partition. Now connect this to the left side and connect it to the right side, and the first one is surface, and I want to use the subtract. Okay, and if you look at if you change the section slowly, you can get the section of the Ammonite or the nautilus. Cool. Now it itself is already look like an Ammonite shell, but I would like to add some detail as well. If you look carefully to the Ammonite shell from outside, You see there's some wave on the shell, like these, or like these. So I would just like to add a simple wavy patterns on the surface, like these, so that it would look a bit more realistic. So, and let me just call it like a shell wave. So let's add some additional parameters here. First of all, I would like to have how much it should, how much the wave height is. So I'll say shell wave height, shell wave height, and set the range to, I don't know, around from 0 to 1 probably. And let's make another parameters. Shell stands for shell resolution, shell res. Okay, and the range could be around 0 to 10 probably. Yeah. Apply, or 0 to 5, I guess. And where I can use these parameters. Okay, for the wait a minute. For the shell resolution, I can set the minimum to 1. Okay, for the shell resolution, where I can use is that I can, if you look at this here, you have those points, and what you can do in order to add the wave on the surface, you just need to kind of modify the P scale that you already have. So what you want to do is that add some wavy value to the current P scale. So I guess I can make a new point wrangle just after creating the spiral curve. And let's get the parameters. Float shell wave height equals to CHF controller shell wave height, and another one, float shell resolution CHF controller shell res. Okay, so FP scale. Let's add the shell wave height times using the sign at each point number times pi divided by shell resolution. By this you can control the wavy frequencies and the amplitude, probably. Now let's look at the sweep result, and let's change the value here. So if I change the shell wave height, yes, it's not, oh yeah, if I change the shell resolution, it is changing the surface to be the wavy pattern. Now the problem I have, obviously, is that the wave is a bit too pointy, but it's okay because I'm using normal after merging it. So if you look at the normal, it has less pointy, but it still has, so I'll set it to 180. Okay, now it's good. Now you can control the parameters to get a realistic looking wavy patterns as you like. Yeah, probably like this. Good. Okay. And if you get the section of this geometry at 1, you'll get the geometry. It's a little bit taking time to get a section. It's geometry. Okay, now I seem to have some problem with the boolean here, so let's set some parameter. What I need to do, I need to turn off this one. Assume seam polygons are flat. If I turn this off, I think this one should be fixed. Okay, yeah, looks good. Now it's all looking good. And it's kind of almost mostly done here. There is one more parameter that I want to add. I mean, I can just finish it here. Maybe if you're enough listening to this one, I think you can just finish here. I'm just gonna make a color, but if you're still interested in adding one more parameters, then I'll show you how what I can add for this one. Okay, I'll set the section back to 0 and probably the height to be around like this, and let's set the color. In order to set the color, first I would like to set the point, make the point wrangle, and okay, I would like to get the minimum and maximum of the Y position. So first of all, I need to get the minimum bounding box position using get bbox min on 0 input vector max and I'll set the color attribute fit. So I want to change the Y, current Y value from min Y and max Y to 0, 1. Okay. Now I can use the color node to use the ramp from attribute and use the call and set some colors for this Ammonite. Now since it's a fossil type, maybe I can use the dark browns somewhere around here. Okay, and make it a little bit brighter, but yellowish. And a bit more yellowish. a bit orange, I guess. Yeah. I would like to make this a bit darker. Okay. A bit. Let's move this a bit more to the right. Okay. Let's move this a bit right. Okay. Now, what I would like to add as an additional parameter for this one, I saw an article about the theoretical morphology of a Nipponitis. A Nipponitis is one type of Ammonite used to live in the area of Japan, around Japan. And it says that some Ammonite, this Nipponitis Ammonite, not just rotates its shells on X and Y direction, but it also rotates on Z direction with using the additional axis like these. So, and make a shell looking like this. And I thought it would be interesting to implement this as well, so I would like to do that. Now, the place where it explains how it's rotated, it's somewhere, yeah, around here. This one. Now it's written in Japanese, so you won't probably know what it's really saying, but X and Y is written here. It's simply the same equations that I use for this one, but for the Z it's using a different kind of parameters, so let's try to implement that as well to make it more three-dimensional. Okay, I need 2 more parameters for this one. One is C and another one is D. Okay, apply, accept. Now where can I use that is I can go back to creating the spiral and I can just use C and D here to change the Z, or in this case Y direction, since it's using the different X, Y, and Z spaces compared to the paper that I was looking at. So let's import the parameter CHF controller C float D CHF controller D. Okay, and let's set the Z value, which is around here. Now before doing that, let's check the equations again. Now you can see that it's using the sign and also changing a bit of a radius, or R. R itself is different from the R used for the X and Y direct coordinates. So I need to change that one, and I also need to change the angle as well, the theta. So let's go with the theta. It says in the paper that it's multiplying theta with a parameter called D, so I'll just use D to multiply the current theta. And let's go to the Y, which is upward, here and use R times C. So I'm suggesting this one to be R times C. And times sine theta 2. Okay, that's it. And now if I change these values C and D, it's changing the value like this. Now D stands for the angle, I mean the frequency of this z direction's sine wave. The C stands for the height of this wave. So the C could be the maximum of the C could be 1. So I'll set the range to 1. D, I guess it's this fine. Maybe a bit too big. Maybe I'll set the maximum to something like 4. Okay. And now as a result, if you look at the colored, now looks interesting. Well, it's a bit too aggressive. Yeah, it does really look interesting. And it does look a bit realistic than before. And let's change the D to more frequent, like 4. Or 1. Yeah. If you set it to 0, it's gonna be just normal as before. And let's also make the section and if you change the wave or the D like this, yeah, it's pretty much interesting. Let's set the shell wave height to 0 so that I can make the section a bit more faster. Or let's set the D to 0 and make the section cool. Set the wave height a bit larger to make the wave. Now this end's a bit slow. I guess the Boolean part is taking a lot of time to resolve the subtraction of this geometry. Yeah, but it's still interesting. And I do believe it does look like an Ammonite or a nautilus shell. Okay. Now I can also switch between Ammonite and nautilus. Yeah, that's it. That's about it. How you can make a Ammonite shell or nautilus shell parametrically. Okay, that's it. Thank you.